Hi everyone, welcome to this new video. Today I'm going to start a series of video about a common case or a common process that we have to deal with when we are working on a machine learning project. I'm talking about model tuning. And what is model tuning? Well, model tuning is the process of finding the optimal hyperparameters to maximize model performance. What is a hyperparameter? Well, a hyperparameter is a variable or value that we cannot learn from the training process or the training data. Instead, it controls the training process. For example, the number of estimators in a random forest could be a hyperparameter. Now, there are several methods or tools that we can use to perform this hyperparameter optimization. However, um, in the next videos, we are going to work with Hyperopt, which is a, let's say, very common and popular Python library for serial and parallel hyperparameter optimization. So I would say that it's a very good idea to have experience with this tool. So let's get started with the first part of this series, and I'm going to start by sharing the screen. So this is the script I have prepared for this video. But the first thing that we are going to do today is to create a function that returns training and testing data to do our experiments. We are not going to use a real data set. We are going to use, let's say, artificial data. And to do so, I need pandas. I also need scikit-learn, import make classification. Yes. And that would be enough for now. So let's create that function def create a data set, something like this, right? And this is going to return a data frame. Creates a data set for testing purposes. Yes, exactly. And it returns a data frame. Um, so in this case, we had to do something like this. Make classification. And here we can pass a number of parameters. For example, n samples is going to be equals to n samples. Any features, any informative, yes, that's okay. I am not interested in this one. Random state, yes, that's okay. And let's make that parameters. Let's make those parameters. Any samples, let's say, so that we can experiment later. And this is an int, right? And any features, how many features do we want? Let's say 50. An informative int, this is the number of features that are, let's say, providing prediction power to the model. Let's say that 10. And random state, let's say this is this one, right? Now let's create a different, just exactly columns, but I like any features and features. Let's say feature, yes, and exactly, and return df, right? Let's use some formatting here. MLflow utils. That looks okay. Now let's see how this dataset looks like. Let's use from no from MLflow utils import create dataset, right? Now let's do something like this. Oh no, I just want to print the data frame, right? Let's run this code. Python 24. Okay, we have our, let's say, demo dataset or artificial dataset. We have a binary problem here. which means that we only have two categories, 1 and 0. So this is going to be a classification problem. Now let's talk a little bit about Hyperopt and optimization. So let's let's say that we have the next problem. Let's say that we have a function like this. This is a simple, let's maybe make it a little bit different, something like this, right? Something like this, we have this function and we want to find the minimum of this function. In this case, it's very easy. In this case, the minimum could be this value, right? It could be -1, -1, right? Let's say that I decide to move this function to the right. Well, in this case, the minimum value is 1. Why 1? Because if I evaluate the function in 1 here, uh, this function, it's going to have the minimum value. In this case, 1 minus 1, 0, 2, right? That's what we are seeing here. This is the minimum value. There is nothing below that. So now let's try to find this minimum using Hyperopt. Then we can extend this logic to a machine learning model. So I'm going to go here, yes, and I'm going to import some things from Hyperopt. Of course, if you don't have Hyperopt in your virtual environment, you can do pip install Hyperopt. Okay, and it says requirement already satisfied. Now let's do from Hyperopt import if mean, yes, from Hyperopt. I like to use this notation and trials. Okay, now let's create an objective function. Now, the objective function is what we want to minimize, right? In this case, well, we only have to write this function, right? It's like this, right? So we can do something like this. Y equals to, yes, something like this. So let's say that this is called x. It's the same function, right? Let me check. Oh, we need +2, right? Let's say this function return y. It's exactly the same function that we have in the browser, right? Here is the function, the same function, but in this case, I am using Python notation. Now the idea is to find the minimum of this function. Now let's use Hyperopt to do so. Let's do first, let's define a search space, right? Um, well, in this case, it could be something like this, right? From -10 to 10, that makes sense. Now I need from Hyperopt import HP, right? This one. So this is the search space, which means the Hyperopt is going to look for uh, in this range of values, right? From -10 to 10. Okay, this is the search space, of course. And in this case, it's because it's a very, very simple function. Um, let's say that we are dealing with more dimensions. Well, we are going to have more parameters. Now let's define trials. Let's define best or the minimum. And here we need basically these parameters, right? We need the objective function. This is what we are going to minimize, right? The search space, here we are. The algorithm, here we are using TPE suggest, and basically here we are saying, hey, use Bayesian optimization in this search. The maximum evaluations and trials. Trials is an object that Hyperopt uses to track the history of all the trials, basically. Because this is not a random search, there is a Bayesian process that Hyperopt uses to find the best hyperparameter or the best values for this parameter. Now let's run this code, print, and here from this figure, we can say that the minimum value is 1, right? 1 is the minimum of this. Now let's run this code, Python 24, almost one, right? Which makes sense. Let's say that I want to move this more to the right. Let's say something like this. Now the minimum is going to be 3. How can I do this? I can just change this, right? Let me run this. Almost 3, right? Now let's try with, let's say, negative value. Let's say that this is to the left. And let's change that here. Let's run Hyperopt, and it's -3, right? Um, so that's basically the idea of Hyperopt. We're going to find the minimum of a function. Basically, the main challenge um, when we are working with a machine learning, let's say, project or case, is that we have to define this objective function. In this case, it's very simple because, well, it's this example, right? But when we're working with a natural model, this might be, this will be more complicated, especially because we want to track all those iterations using MLflow. So in the next video, we're going to start incorporating MLflow here, see what happens. So that's everything for this video. Thanks for watching it and see you in the next one.